Hey everyone. Here's the follow-up, the solution to populating next right pointers in each node, and the breadth first search approach that we took to solving this. Right? So if you watch the hint, you saw about this much, right? We create our connect function. We create our edge case that says if there's no root, return null, and we initialize our queue to the entire tree, which is the array bracket encapsulation, or the array encapsulation of our root parameter. So as I was saying in the previous video, that you probably thought of doing something very similar to this, right? While the queue's length is not 0, right? Because we're going to be adding and subtracting onto the queue. This is a very natural statement to write. This is not as intuitive. So the queue's length is going to be changing, and it's important that we capture that length variable, because we have to reflect those changes in the queue in order to properly process them. So within the queue now, we're going inside the queue. We're pulling the node, right? So we're shifting the queue. We're taking the parent node off of our queue, and we're processing now our left and our right. They're getting put onto the queue. I think most of you probably figured that out. Where I kind of got stuck, and I'm sure many others did, is what to do with node.next. How do we actually, do we add the pound sign? What do we do, right? So this is important, right? Because we've removed an item from our queue, right? So if it was 1, 2, 3, now it's just 2, 3, right? Because we're processing node 1. And so queue at 0 is the next node in the queue, right? So node.next is equal to queue at 0 always, because we're going to be running through until the queue is empty. And so this part right here is also important. We talked about our O of V plus E runtime. So every time that we process a level, our queue reinitializes, so to speak, right? We process node 1, it gives us 2, 3. We process 2 and 3, it gives us 4, 5, 6, 7. And so when we get to the end of our queue, we have to set node.next equal to null. And that's what's going to give us our our hashtag pound sign, value. And then at the very end, you're returning the root. And if you are less familiar with the more advanced ideas of how objects work, you might be like, well, why are you returning the root? Objects are references in memory, right? And so we're mutating this entire object, the root, the tree. We're going through it, and we're changing these node.next values as we're going through it. So you're actually going to be returning the entire binary tree back. But the binary tree has been mutated now. It's an intentional mutation, and that is part of the actual instructions that you are supposed to be intentionally mutating the tree. You're not returning a copy of it, although you can if you really wanted to. You're returning the original tree. So that's everything in a nutshell. If you guys are confused still, you can always reach out to me. But I think this is a very, very good example of how to implement a breadth first search, right? You can really see it. You're inside the queue, and now and now the queue's size is based on based on the nodes that you're processing, right? So first it's just one gives you 2, 3. Then it's just 2, 3. 2 gives you 4, 5, 6, 7. So you have 3, 4, 5, 6, 7, and then you have 4, 5, 6, 7, right? So it's yeah, that's all of it. And submit it if you'd like, although I already did. And there you go. All right. Have a good one.